Hello everyone, I'm Yukon Pan, and this is my final project for CGT 620. It's Sparse Voxel Octree. Well, in 3D computer graphics, voxel represents a value on a regular grid in three-dimensional space. It's similar to pixel in 2D. And a naive voxel grid is extremely memory consuming. We will waste most of memory on space that doesn't contain any geometry. By using sparse voxel Octree, we can avoid memory wasting, and we can also get high performance of recasting. For voxelization, which is the process of creating voxels, I launch one thread per triangle, and I conduct triangle voxel collision test in triangle's bounding box. I also use pre-computed data that will be used in collision test to speed up. And for Octree construction, I did this in a top-bottom manner. This is the flowchart for the construction. So I first mark every parent node that need to be subdivided. Then I allocate a child node. Then I detect whether it reached the max level. And finally, I assign voxels in all the leaf nodes of the Octree, and I map them from bottom up. And this is a recasting algorithm. It's a recursive method, and I use the CUDA stack to support the recursion. So it's a very simple method, and this is my CUDA implementation. So my voxels and octrees, which are all classes that are stored in 1D arrays in global memory. I also use a global atomic counter to indicate the current index so that the voxel that is created in parallel can be stored in the correct index of the 1D array. And for the colors and normals and other values, etc., I store them in an unsigned integer so I can save memory. Also, CUDA supports recursion, which is very convenient for the recasting implementation. And this is my performance analysis. So I use the Stanford Dragon, which contains around 1 million triangles, and my voxel resolution is 512 power of 3, and my graphics card is GTX 1080. So you can see the sparse voxel Octree saves tons of memory compared to a naive 3D grid. Also, my recasting performance is much faster. And although the construction of Octree is slower than the naive 3D grid, but it's still quite short time, compared to the time spent in recasting. So let me show you my demo. So I changed the model to Happy Buddha, and this one contains, I think, 1 million triangles, and the performance is quite amazing. It's around like 70 frame per second, and yes, it's the same voxel resolution. I also try to add semi-transparent properties to the models. I render it using kind of like a path tracing algorithm, but I get some terrible results. So you can see the refractions are correct on the whole, but there are some glitches. I believe it is caused by the resolution of the voxels are not high enough, and also there are some discontinuities between the voxels. Well, as far as I'm concerned, voxels are better to be used for visibility test or indirect illumination, instead of directly rendering it. And for optimization, I use some bit masking parent node, so I can read it from registers instead of global memories. Also, I tried my best to maintain my reading and writing operations to consecutive locations. Also, I switched the order of some conditions. So I always first test the condition that is faster to compute. And also, data compression can increase the efficiency significantly. Well, here are some lessons I learned. Well, CUDA is a very powerful and convenient tool compared to compute shader in OpenGL. Well, I also learned how to optimize code based on memory management, how to handle caching problems, and also a voxel is better to be used for visibility test and indirect illumination. I think there are some papers about it. They used voxels for a visibility test, and they use cone tracing to generate indirect illumination, and they all get pretty results. But voxels do have some problems on specular reflections, and also when you, if you directly rendering it, you will see some blocky effect when your camera is too close to the voxel. Also, voxel's time complexity is related to the area of the mesh, not the triangle amount of the mesh, which is quite a good properties in rendering. So future work, I was thinking I could continue to add cone tracing to get voxel-based indirect illumination, while I also want to explore the possibility of dynamic updating of the Octree. This is also the topic of my thesis. So I will add some functions to edit and undo the changes of the Octree in real time. Well, that's basically my final project, and thank you for watching.